Greetings and welcome everybody to Chapter 2-5, Solving Equations Involving Absolute Value. Let us understand our learning targets for today. Today we will be evaluating absolute value expressions, and we will also be solving absolute value equations. So how do we know that we're going to be successful today in this endeavor? Well, simply put, we will be able to evaluate multi-step absolute value expressions, which result in one solution. Furthermore, we will be able to solve multi-step absolute value equations, resulting in either one, two, or no solutions at all. So, keep at the forefront of your minds these essential questions as we journey forth together on this journey through Algebra 1. In this lesson in particular, ask yourself the following questions, for their answers will be revealed today. On this lesson, what are the two cases you must consider when solving an absolute value equation? When does an absolute value equation have no solution, and why? When does an absolute value equation have only one solution? We will answer all of these questions and more as we proceed through the day's lesson. So without further ado, let us get started. All right, here we go. Here we go. Okay, so let's talk about, I like to start with funneling in real life and funneling it down into the actual math pieces. So let's talk about life for a second. In various facets of life, you will want to consider perhaps maybe the distance. So let's write that word distance. Something is away from a fixed point rather than its direction of approach. So, for instance, let's say that you are expecting guests to arrive at your house. You might ask the question. You call them up and say, how far away are you? That might be the question you ask because you don't care if they're coming from east or west or north or south. You care how far away they are. That is what you are most concerned with at that moment in time. Similarly, if you conducted a survey of students about their opinion on an important school topic, now the topic doesn't matter, but you may come up with a measurement of the margin of error. And in doing so, it would give you a sense as to how much more or less the result is from, let's say, for example, a fixed point such as the average. You may also hear the term deviation, right? But average would be the fixed point, and there is some movement away from it. Now, this whole concept of distances away from things really encapsulates what absolute value is all about. Absolute value enables us to remove direction from immediate consideration from the problem at hand in order to focus on distance, for that is our primary concern. And you see, once distance is known, so let's go ahead and write that. Distance, once distance is known, we can then establish let's say, a range or a spread of values at the most directionally opposite ends of the fixed point, beyond which the values are invalid. In fact, not even just beyond, even in between, right? They uh, that's the whole idea is we want the distance, just the set distance between our fixed points. So you have the example here of how far away are you from, let's say, your friend's house. You have the example of surveys and margin of errors. Let's take that and get some more math sense going out of that, all right? Let's look at this here, for example. Here's what you'll see when you start diving into these problems, okay? Let's look at this equation here, for example, this one right here. Now, the way you first want to read this, you want to read this as this says the absolute value of x equals 4. That's how you should read this. And these vertical bars here, these vertical bars straight up and down are the symbol which indicates everything inside is being absolute valued. Okay, so understand that what you're seeing is that when we start working with it, it makes more sense. Now, what exactly does that mean, though? Okay, that's great. I can recognize this symbology here. That's wonderful. That's good. Now, what does it all mean, though? Well, this means basically the distance between 0 and x is 4. So the distance, so so this whole thing it produces distance units. This 4 would be I'll say it's unit, a distance unit. Okay, and what do you mean it's between 0 and x? What does that even mean? I don't, is probably the question you have. Well, basically what that means is that in math, there are lots of different functions and equations and so forth. This, in fact, is a function, and you don't need to know what functions are specifically today, but understand this is a function. We'll talk a lot more about functions. This is a function, and most of them have starting positions and default values at 0 or at the origin is another way that it'll be said. So when we want to assess distance units mathematically, we're not we don't have the context of here's my house and how far my friends are from it. We don't have the context of here's the average sort of opinion on something. We have the context of just pure and simple numbers, and the most central fixed point of all these different numbers and integers and so forth in math is 0. So that's our starting point when we consider working with pure equations, which we will, many of them. But, but, while this does produce distance units, we don't want to forget about this idea that we need to understand where the direction is on this. So math models real world problems, and in the real world, it is important to know the direction of approach toward a fixed unit or away from a fixed unit. So we need to factor that in, and we will. Once we are in a position to determine the amount of distance units, so once your equations, let's say, if that's what you're working with, once your equations are in this form where the absolute value term is isolated on one side and it equals some stuff, then we can start to consider directions. And on a number line, let's say like this illustration here on a number line, those two directions are primarily left and right, or positive and negative. So negative being left, positive being right. Like I say, once we get it in this sort of form, just like if we were to solve an equation, right? X equals stuff. I always say variable equals stuff. That is the goal that we're trying to achieve when we're working in mathematics and trying to solve for variables in equations. So it's very much the same idea. In fact, I would even go so far as to say that you should treat the entirety of an absolute value term like a variable. In fact, you kind of have to in a lot of cases for you to be successful in solving these problems. So when you see this, just think that this itself is a variable and treat it as such. You're going to see just plain old x looking like this, sure, but you're also going to see some other things happening that might sort of bend your mind a little bit as we go forth here. So before I start bending your mind here, let's just kind of put this into perspective here. I have this number line illustrated here, and again, I'm saying absolute value of x equals 4. So I'm saying that I don't know the current direction. I know the distance units away are 4. I don't know if it means I'm starting here at the origin at the 0 and then going left or negative. I don't know that, so that's a potential option. Or I don't know if it means I'm going this way toward my destination, which would be in the positive direction. So that's a valid option. Both are valid options without me knowing definitively what the direction is. So in order to answer the question, I am to say that there are two possible answers, and this is how we notate this. Two possible answers here. One possible answer, again, is saying, okay, yes, I'm going toward the negative direction. So that's where this -4 would come into play. And the other option would be, yes, I'm going toward the positive direction. That's where this +4 would be going into play here. And this, again, with the little brackets, the brackets like that, with the two numbers in the middle, right? That's what's called set notation, or let's see, set notation. You'll see that a lot. I'll use it a lot here. You'll see it a lot in various mathematical texts. Don't be confused by it, really. It means all this that we've been saying in words. It just means that. It's just a nice condensed way that mathematicians have decided to basically put all these words in symbolize all those words. So don't get confused when you see it. It just literally means two potential numbers, right? The comma separates the two potential numbers that x can be to make it true that the distance is 4 units from 0. So with that said, let me circle back here. And I said a few moments ago that this is fairly simple to grasp here. Treat this like its own variable. It kind of looks like its own variable, but when you start seeing stuff like this here, and this is why I really want to emphasize to envision this as a variable first and foremost. You have this. This is what I like to call the default version of absolute value. But you're also going to see things like this, where you have perhaps maybe x minus some number or x plus some number. You're going to see all sorts of craziness going on here in the middle of these absolute value bars. It's going to be all sorts of hoo-ha, nonsense, whatever you want to call it. Recognize, though, uh, what I want to say about these here is that when you see that, I want you to understand that whatever else besides X is happening in here, I want you to really get this understanding that those are transformations. It is transforming the starting position. If X itself is 0 and it is the starting position, just plain old this is the starting position, then anything that happens to X, so for example, absolute value of X minus 1, right? You're saying that you're modifying your starting position here. So when you see things happening to X, so whether it's that, whether it's this, whether it's all sorts of crazy stuff going on, you're saying that your X there is undergoing a transformation of X, and thus the starting position or fixed point. Uh, Starting position or fixed point. Okay, now I don't necessarily want you to really memorize this yet. You need to know it at some point, but it's probably very abstract at this moment. I don't want you to simply go out there and memorize it right now, but understand that I've included this here as a reference as you maybe work through some word problems that may ask you, hey, what is the starting position given something that looks maybe like this? What is the starting position? And then you would look here, you would recognize the minus symbol, and you look here, if you see x and then minus symbol, some number, it means we are concerned with distances from a fixed point of positive some number. So if you saw this, for example, you would say that the starting position has been modified from 0 to now 4. Again, it's very abstract right now. I get it. Just recognize this is included here as reference for you to see as you perhaps work through some word problems. But I want to spend most of the time that we have here today working on not word problems, just straight up pure examples so we can get a real good feel for absolute value. I think absolute value is something that requires just a couple of doing it just a couple of times before it clicks. And once it clicks, it just makes all the sense in the world, right? And it's not so scary and abstract once you do a couple. So let's do a couple here. But I want to say, before we even get started here, I can sort of summarize a lot of what I'm going to say in saying this. When you have stuff in the middle of absolute value bars, what you are doing is, or whatever it is, whether it's a number, whether it's a variable, whether it's whatever. Let's say in this case, since we're working with expressions here, a number. What you are saying is that this is the what this ends up being is distance units. I want to be very clear in saying that the output of an absolute value term or expression or equation is distance units. And if you think about distance, like distance that you travel in a car or on foot or whatever, distance, you're always going forward in distance. There is no such thing as negative distance. So for example, if you had something like this, right? This is saying that that x is -1 distance units away from 0. Well, it doesn't make any sense. One, distance isn't negative, but also the whole point of absolute value is to remove direction from consideration, and negative is direction. Positive is also direction. That's why I'm very particular in saying this is not -1. This is not even +1. These are distance units. So keep that terminology in mind as we move forward, and I think it will be very clear once we start going through some of these examples. So that's all I wanted to say. All I wanted to say. So let's do some. So I see here, once I have whatever's inside my absolute value bars, whatever is inside, once it is in simplest form, in this case it is, I can do nothing further to this 4. There's no variable to modify. There's nothing more that I can do to reduce or simplify this. It is in simplest form. Then it undergoes a transformation. The transformation being uh, produce or produce an output of distance units. And so the output of this in terms of distance units is 4. There are 4 distance units right there. Okay, boom. I've undergone the transformation that these absolute value bars are indicating. Transform into distance units. So this pure value of +4, transform it into distance units of 4 right there. And so the rest of this just comes down, -9. The answer here is -5. That is the answer, -5. That is the answer. Let's look at this one here. So once this is in simplest form, I can then perform the transformation of taking the values and transforming them into distance units. Right now, this one is not in simplest form. There is stuff that can be done to consolidate this down into a single numeric value. You can do inside of these absolute value bars, you can perform the operation indicated here for -9. This itself is -5, and you still have the absolute value bars. Now that you have this -5 as its own separate entity, as its simplest form. Now you can perform the transformation of taking this and converting it, transforming it into distance units. So -5 is, I don't care about negative, it is simply 5 distance units, the value. That numeric value is what's important, the value of distance. Don't care if it's negative. In fact, if you see absolute value anything and it's negative some number, right, you can just sort of envision in your mind it's going to resemble, it won't exactly be, it's not right to say it's +5, it's right to say it's 5 distance units, but you'll most often associate this with simply just saying positive 5. And so you'll just develop this association with absolute value that whatever is inside, negative or otherwise, just comes out positive. If that's how you want to think of it, that's okay. It's more appropriate, though, to say that these are 5 distance units and not simply just positive 5. Again, because the whole point of absolute value is to remove direction from immediate consideration to simply focus on distance. Before, then, later, factoring in direction, which we will later. Anyways, 5 distance units here, and in fact, the answer is indeed 5. Let's look at this one here, okay? It is in simplest form. Transform this into distance units. This is 6 distance units plus 9. That equals 15. Right, again, whatever's negative in here, if it helps your brain to think about it as becoming simply positive, then there you go, positive 6. Whatever gets the point across in your brain is and gets you the right result is okay with me. Anyways, so that's 15 there. Let's see, this is not yet currently in simplest form, so minus 6 plus 9 happens to be 3. That now is in simplest form. Transform this into distance units. That is 3. There's nothing on the outside, so the answer simply is 3. So 3 and 15, these are the answers here in this box. This is not yet in simplest form. Make it into simplest form. This becomes minus 5 plus 7. This is 2. Okay, I still have the absolute value bars. Now this transforms into 2 distance units. So that's the answer here, 2. This here, simplest form already. Yes, indeed. Now let's transform this into distance units. This is 5 distance units. Plus 7 equals 12. 12 indeed is the answer here on this one. This here, it's already simple form. Transform 6 minus 7 equals -1. This is not in simplest form. Doing so gives you -1 though. Putting it in simplest form gives you -1. Then from here, let's transform this into distance units. So this becomes 1 distance unit. So there you go. These are your 2 answers here. Again, nothing too bad, nothing too strenuous here. It's fairly straightforward when you're working with expressions and numeric values, and I want to emphasize the points here that when you are working with absolute value expressions, you will produce an output of not just distance units. Yes, that is true, but more importantly, I want to hit home the point that you will get one solution when you are working with and evaluating expressions. So with that in mind, let's build on our understanding here. These were fairly straightforward. Now let's think about these expressions when they throw a variable in place. Now, and they also have been so generous as to tell us the value of that variable that they're throwing in, which is wonderful. So if they're throwing in a variable and they're telling us the value of that variable, it essentially becomes a numeric expression like what we did above after we substitute and replace and plug in the number here. So let's build out our skeleton. Building out our skeleton means simply not writing m, but instead parentheses with some space here in anticipation that we're going to insert or replace or substitute that blank spot in with what m really should be. So let's see, this is supposed to be m. It's not m, it's blank space, but we're going to put a 4 in that blank space. 4, and then I have out here a minus 14. Minus 14. So just like with order of operations, you can treat in most cases, I'll talk to you in a case where you wouldn't, but these are functionally, as far as order of operations are concerned, very functionally similar to grouping symbols like parentheses, brackets, and so forth and so on. So when you see things like an expression or an equation or something, and it's got these absolute value bars, what you want to do is work everything in the middle first, just like parentheses with order of operations. Work everything you can inside first, and then build out from here on the outside of it and so forth here. So, so let's see here. If I were to do that, 4 plus 6, that's 10. I still have these bars yet. I haven't transformed anything yet. Okay, this is simplified. I can do no further with this. Now commence transformation. Transformation to distance units has been completed. It is simply 10 distance units, not positive, not negative. Uh, it's just simply distance units. Now with that said, I had this 14 to begin with, minus 14. Okay, great. Now I can go ahead and evaluate fully and get an answer of -4. Not too difficult there. Not too difficult there. The key here on this one is replace, substitute, and then follow order of operations. Let's do this one here. 23 minus 3 minus 4, skeleton here. And if x equals 2, this used to be x. Now let's say and put a 2 there. Okay, order of operations, multiplication before subtraction. So this is 3 minus 8 bars here. Okay, nice. So I still have stuff to do in here. It's not fully in simplified form yet. Let's get it there. 3 minus 8, that's minus 5. Okay, now this is in simplified form. I can go ahead and commence transformation to distance units. 5 distance units. Again, distance cannot be negative. You cannot have absolute value equal negative number. Okay, there's no such thing as negative distance, and it just generally defeats the purpose of absolute value in the first place. Figure out distance first, then factor in direction later. Anyways, getting a little sidetracked there. This is 5. This minus sign comes down. That didn't change. This is still there, so that's minus. So you're not saying this is minus 5 as a result of this absolute value. You're saying it's minus 5 as a result of this being 5, and then this minus sign being directly in front of it. 23 minus 5 equals 18. There you go. That's the answer. That's the answer there. This was the answer here. And now we got one more here on this little set. So build out your skeleton, plus 15. So A equals 5. A is supposed to go here. Okay, but it's 5, so I'm not going to write A, I'm going to write 5. Okay, so I got 5 minus 7, that's minus 2, plus 15. Okay, this is now in simplest form. I can perform the transformation from whatever it is into distance units. This is now 2 distance units, plus 15 equals 17. That there is the answer. That there is the answer. So again, nothing too bad here with these numeric evaluate the expression sorts of things. Now there's a couple interesting things happening to these next two here, which I want to get into. But here's where, if you recall, I was a little hesitant to say these are fully just like parentheses, fully just like brackets. There's a slight difference here. You don't, in most cases, you do treat them just like that. But in a particular case that I'm going to mention here in a second, you don't want to view them as parentheses or brackets. You don't. And that pertains to when you may encounter opportunities to apply distributive property. So if you recall, distributive property looks something like this, right? When you have a term or a value being multiplied by a term that is in parentheses, right? You would distribute the 5, give the 5 evenly, so this becomes 5x plus 25. That's what you would do with parentheses and brackets and such like that. But if you had absolute value bars, okay, that is not, you do not do that. You would not be able to do that and get away with the correct result. So as it pertains to, as it pertains to distributive property, do not treat like parentheses grouping symbols, brackets, whatever you want to call it. Do not treat them that way, for you will likely run into the wrong answer if you do. So don't even think about them that way. In fact, it would be most preferable if you thought about, in this case, this whole thing not being uh, anything other than simply just a variable all unto its own self. A variable such as 5x, you wouldn't be distributing the 5 to kind of like how we did here with the arrows. You wouldn't be distributing it. It just is. It just is connected to this, right? You're not distributing, so anything could be happening inside of this x uh, in theory, but you are you're not distributing it to each and everything. You're just multiplying it by the whole thing. That's how you need to look at these when you see absolute value like this. You need to envision this whole thing to not, you can kind of just ignore it. You need to be envisioning it as a variable unto its own in order to be successful. When you see things like this, where you would normally believe distributive property would apply, it won't. And so you need to treat it like a variable. This whole thing like a variable. This whole thing like a single variable. Single variable. Single variable. Let's work a few examples, okay? So let's work these out here. Let's build out our skeleton because we got some variables, we got what they are. So we have information here. We can start building out a skeleton. All right, so let's do that. Let's see here. There's a lot of variables here, a lot of variables. Okay, all right, so I have, let's see, x2, y3, and then let's see, z -4. Okay, well, there we go. All right, skeleton built. Values are replaced and plugged in and substituted. Now, time to execute orders of operations, just as you normally would. Uh, so in that sense, do treat it like grouping symbols. So 2 plus 3 be 5. Now in this case, do not treat like grouping symbols and distribute the negative to both. You don't want to do that. You don't want to do that. Just leave it as it is. Okay, negative, let's see, 14 minus 4, that is 10. So I have an absolute value bar of 10. Okay, now it's in simplest form. Now you can perform the transformation. Transform this into 5 distance units. Transform this into 10 distance units. There does happen to be a negative out in front of it, so this just carries along, goes along for the ride, carries on. Minus 10, or minus 5, minus 10 equals -15. That there is the answer. That is how you evaluate something like this. Again, I want to point out, as it pertains to distributive property, you would normally think it would apply here. Don't do it. You will get the wrong answer if you do. You will get the wrong answer if you do. Do not treat these like distributive property when you see situations like this, because they aren't exactly parentheses. They aren't exactly brackets. So let's look at this one here. Let me build out my skeleton. Let's see, z, what is z? -4, -3, plus 2. I got 3, minus 2. There we go. Okay, skeleton built. Let's start executing order of operations. -4, -3, it's -7. Okay, plus 2 times 3 minus 2 is 1, so there's 1 there. Okay, now this is in simplest form. Undergo transformation. This is 7. Okay, and you're basically have this -4 out there, which is multiplying by it. So that fact does not change. It is still -4. It is still multiplication happening between the two terms. So make sure that that happens. This here, same idea, right? This transforms simply to 1, and it's being multiplied by a value here of 2, and all this is being added to this, and that becomes -28 plus 2, or -26 for final answer. Pretty pretty nifty, guys. Nothing really to it. Nothing super different than what we've learned already with just normal expressions, with uh, yeah, normal expressions basically, where we had to not only solve numerically, which is what we did up here, but then solve algebraically when we substituted in a value for a variable and then executed order of operations. Nothing different at all in this case. Now, here's one now. So expressions. I'm going to close the book on expressions for the time being. And I'm going to go on to absolute value equations. There's a lot to be said here. There's a lot to be said here with absolute value equations. So let's start saying some things about it. First thing I want you to recognize is, let's say you are given a problem. Let's say you are given a problem. I need you to recognize first and foremost the basic, basic, I'll say, options or paths you can take. You can have, so there's three primary options here that one can take, and we'll see examples of all of them. Right, but I want to give you the overview now. You'll see, I'll say this is option one, right? You'll see the option one being where this equals some positive number and is thus going to result in two solutions. You can sort of write this off on the side somewhere, wherever it makes the most sense for you. This would be option two, and that would result in, let's say, some sort of negative number. That would thus then be no solution. And then you would have option three here, which is saying that this is 0, and thus there is only one solution. Solution being in reference to the value that the variable can take on. Okay, so I want you to have this sort of overview of the different options that these equations can result in, for we will be looking at each one in the following examples. Recognize further that you must achieve this general structure before you can even make your decision path. The general structure being you have absolute value, whatever's inside, but it alone is on one side of the equation and it equals some other stuff that's going on. So it could be simply just an x equals whatever, or it could be something much more complex like this f plus 5 equals whatever. This f plus 5 equals whatever. The point is that this absolute value term, and yes, this is indeed its own term. This is a single term, and the way we write it, that itself is equal to some stuff, just like x equals stuff. So the general format and structure, I hope you're seeing that. It's isolated. This right now is what I would say, what not just what I would say, but what is. This is indeed in an isolated form. So let's see, let me just erase some of this here and we'll work this example here. So as I said, once you have this isolated and it equals a positive number, you have potentially two solutions. Two solutions. You have, remember the idea here is that you can start from 0 or the point that you're starting from, and you can proceed either right or left. Right being positive and left being negative. And we don't know which direction we're going off to, so we need to consider that whichever one, right? We want to cover our bases. We want to have room to say we can, come from the left, come from the right, go to the right, go to the left. Doesn't matter there. So we have to consider both cases. The case here that we are going to go off in the negative direction. So we're going to set this original term, this simplified term, set it to negative, and we're going to do the same here, but set it to positive. Again, it's the distinction, the difference here is saying that, hey, it could be 17. It's telling us it's 17 distance units away. 17 distance units away. That is the answer. But it's saying that it's the answer, or this is the answer that makes this whole statement true. But what it's saying, more fundamentally, is it's saying that, yeah, it's 17 distance units, but we don't know if it's from the left or the right. So we need to figure that out, and that's what we're going to do. Anyways, here, so this you would normally, as I've been saying on the previous examples, this would undergo a transformation to being, um, distance units. And that's true to an extent. And if I didn't have it broken out like this, negative case, positive case, I would simply use that phrasing and terminology. But basically, when you have it kind of branched off like this, here's one branch, here's a second branch, like I've done here, I can sort of simply, I'll say air quote, ignore the absolute value. So really they just drop off. And this, well, I wouldn't say transform. What I would say is, uh, it is, right? So it equals negative 17. And then now you can see this now is just simply a one-step equation. So F equals negative 22. And here, again, we're going to sort of simply ignore this. And F plus 5 equals 17 minus 5 minus 5. F equals 12. So the way we write our answer would be to say that the solution to this problem is that x can be either 22, negative 22, or positive 12, depending on the direction that we're looking at. And when we do plug these in, substitute, we are proving thus, and maybe I'll work one real quick just to give you a sense of what a proof would look like for this. But basically, let's say, so on the negative side, I'm saying f is negative 22. Okay, so negative 22 plus 5 equals negative 17. Work this, negative 17, okay, equals negative 17. Okay, okay, yeah, I mean, look here, look, 17, 17, true, true. So it kind of sort of does indeed make sense here. Okay, all right. Anyways, where am I going with this? So solution set, you would write it like this. Here's your first answer. The smallest of the two numbers first. You list them in order. Right, so I got this, I got two solutions, thus one number separated by one comma, and then the other number, so two possible solutions. Okay, here we go. Here's the next one. Here's the next one here. So here is a case in which, as I mentioned not too long ago, a case in which we have absolute value, so in this case, b minus 1, and it equals some negative number. Now, if you remember before I erased, I was saying that when you have a situation where this is indeed isolated, and does indeed equal a negative number, as the statement of truth here is telling us, it is a negative number. Well, you're going to have, well, think about this for a second. Absolute value produces distance units. Is there a such thing as negative distance? When you travel a distance. You cannot take back the distance you traveled, even if you go in reverse. You're not not traveling some distance. You are traveling distance, whether you go forward or backward. So so that general idea is to say that you cannot have absolute value equal a negative. So let me even write that. Can't be negative. It just simply defeats the whole purpose of absolute value. Absolute value is to remove consideration of direction. And when you have an answer like this where it is negative, you are considering direction. Thus, you are violating the idea of absolute value in the first place. Can't be negative. There's no such thing as negative distance. Okay, thus you are saying that there is no possible solution which would make it true, or there is no solution to the variable b which would make it true that this is going to equal some negative number. So there's no solution to this one. So that is, I mean, that's pretty nice and convenient. You see it, you recognize it right away, you save yourself a bunch of work. So when the absolute value equals negative number, just think no solution. Okay, not that bad. Let's try a couple more here. Let's try a couple more, all right? We have here a situation where isolated absolute value equals positive number. This should trigger you to think I will have two solutions. And in math, on a number line, our two options are based on positive and negative versions of our distance units, which is this is saying that it's four distance units. So I have to consider that this is, let's just say this is 0 and this is -4. We have to consider that direction does play a role, and we don't know what it is, but we have to assume, we have to take some assumptions here to cover our bases, either or. Anyways, two solutions here, two solutions here. Recognize that, for it should give you sort of a sense, maybe even save you work in some cases. So let's see here. This is in simplest form. There is nothing further I can do to make this any more simple than it is. Thus, thus you can simply just drop the absolute value, bars. Is it undergoing a transformation? Yeah, I guess technically, to the distance units. I mean, you could say that if that also works here, but the way I think of it is just the bars, they just drop off. So, and you're left with -2 or +2 equals -4, -2, -2. This becomes y equals -6. That's part one of your answer if you look at it from the negative perspective. Now let's look at it from the positive perspective. Let's see, y plus 2 equals 4, -2, -2. This becomes 2 equals y. So when you look at this scenario from the positive case, then you get 2. So your solution set should look like this. Smallest number goes first, and it goes in order, and then you get bigger number, -6, 2, just like that. That is the solution set. All right, let's try another one. Let's try another one here. Let's see, I got this absolute value term. It's pretty complex. It looks pretty, that there's some work to do, but not so fast. I recognize something here. It is isolated, but it also is saying it equals some negative number. Well, again, you cannot have a negative distance. There's no such thing as negative distance. You are always moving in forward motion. Even if you're walking backwards, driving backwards, it is still an amount that you're moving. You can measure it, but it's not negative. There is no negative distance. Anyways, here we go. So let us, I got so let's see, negative number here. Okay, actually, can't be negative, just like before. Can't be negative. See, can't be negative, and can't have negative distance. Can't have negative distance. Okay, so that basically applies to both these here. All right, not too bad at all. Not too bad at all, indeed, indeed. So, oh yeah, wait. Yeah, can't have negative distance. Thus, there is no solution to the variable that would make it true that something equals -1. There's just there's no logic there. There's no truth there. There's nothing that n can be to make that true. Anyways, next stuff here. Here we go. Here's a couple more. We're increasing the complexity level, increasing the difficulty level. But I think you guys, you got it. You'll be able to do this, no problem. Let me run through an example here. Again, once again, I have isolated absolute value term equals positive number. I should automatically think this is going to have two solutions. And I said positive number. I actually meant to say distance units. Distance units, not positive 20. Positive indicates direction. I just want to stick with the terminology saying that these things that they are equal to are distance units. Anyways, this is my preference here. Let's branch. Let's branch off here. Positive number, two solutions, one positive version, one negative version. So this here becomes simply for t minus 8, negative 20, plus 8, plus 8, for t equals negative 12 divided by 4. And I'll write over here, this is simply t equals negative 3. Okay, nice. So let's see here, the bars, this is in simplest form. There's nothing further I can do. So the bars are going to drop off. 4t minus 8 equals 20. Let's see, plus 8, yeah, plus 8. 4t equals 28, and divide 4, t equals 7. So now your entire solution set is this. Negative 12 over 4, negative 7. There we go. Okay, let's do a few more, guys. Do a few more. Let's look at the basic equation that it gives us here. This, is it isolated term? It is indeed an isolated absolute value term. Now, what is it equal to? A positive number, negative, or 0? And in this case, it is positive. Thus, we have two possible solutions. All right, so two possible, one being 6 distance units from 0 going in the negative direction, 6 units away from 0 going in the positive direction. So here we go. I've got both cases represented. Let's see here. These simply drop off. Negative 6. Okay, now I'm going to minus the 6. Minus 6 equals negative 12. 12, and then this y becomes, and it's all said and done, this becomes just simply a 1. And let's see, this simply drops off these bars here. Negative 2y plus 6 equals 6, minus 6, minus 6. Negative 2y equals 0. Divide that, y equals 0. So, I'm sorry, I said this was 1, I meant 6. Anyways, the solution set here is 0, 6. That's how you would write it. Y can be either 6, and this results in a true statement if we're talking the negative direction, or if we're talking positive direction, y can be 0, and this would still come out to be a true statement. There we go. Couple more. Let's do the next ones. Here's the other one I was mentioning. There's another case. We talked about two solutions. We talked about no solution. Here we're talking about when you see absolute value term isolated equals 0, you are saying that there is only one and only one solution. And you'll see that here. It'll make sense when we work through this one example here, right? So if I'm saying it's 0, I need to assess from the negative direction of 0 and the positive direction of 0. That's why you see this equals negative 0 and this equals positive 0. These bars drop off, and you have x plus 1 equals negative 0, minus 1, minus 1, x equals negative 1. There you go. This one here, bars drop off. There you go. 0, minus 1, x equals -1. Hey guys, look, these things, they match. These match. Thus, it is simply only one solution. And you guys have it here, 1 or -1 is that solution. So you can kind of see mathematically, it does make sense that this results in one solution. So when you see 0, your mind should automatically go to, hey, the answer is going to be just one thing. Let's do a few more. Let's do a few more. We're increasing our levels of complexity here. We are increasing the complexity quite significantly here as we venture forth. Now, here represents a little bit of a dividing line between what we just did. What we just did was cases where, I want to point this out very, very clearly. We did cases in which the absolute value expression was already, this actually should say equation, but already isolated. I'm sorry, no, I was right the first time. Already isolated though, it's already isolated. It's already in the form of this equals stuff. So, so this equals stuff. It's already in that format. We didn't have to do anything. We could immediately branch off into our two different decision paths. The difference here in these next couple is that these are not already isolated, not already isolated to one side of the equation. We must isolate them to, we must isolate the absolute value term on one side of the equation. And this is where, again, I want you to understand, well, actually, this goes back to what I said sort of toward the beginning of our lesson here, in that when you see this, treat it like a variable unto its own. Do not look at this as parentheses for which you can distribute. Do not get confused with what's in here. Just until you isolate it, until it is isolated, until it is isolated. I just want to keep saying that because it bears repeating. Until this term is isolated, treat it as a, just mentally, just a variable. You know, if you want to go so far and take that next step and literally put a variable in its place, by all means, and then maybe say p equals, w plus 3. Whatever works for you to get you thinking that this is a variable. Whether you just want to remember that, whether you physically want to write a variable in its place, but I need you to understand to treat this like a variable until it is isolated. So let's do that here. If this was -8p equals something, and to get rid of this, to get this p all by itself, to get this whole absolute value term all by itself, I would need to perform inverse operations. The inverse of something being multiplied by -8 is to divide that something by -8. So let's do that. Inverse this thing. Let's inverse this thing. -8, -8. Okay, so this would be w plus 3 equals, let's see, this would be +7. Now this is isolated. It is now isolated. This whole term of this absolute value term is completely isolated on this side of the equation. Thus, we can now begin to solve for w further. We recognize the form that it is in. The form that it is in is that it equals a positive number. Thus, we're going to have two solutions. We have to evaluate these 7 distance units from the negative direction, or going toward negative direction, I should say, and going toward positive direction. Distance units. So let's say that w plus 3 is -7 distance units, and we can say that W plus 3 equals positive 7 distance units. Okay, so these bars drop off. Minus 3, minus 3. This becomes W equals negative 10. This becomes W equals 4. Right, did I get that right? Let's see. Minus 7, minus 3. Okay, yeah, I have it right. So the solution set here is minus 10, positive 4. That is indeed the solution set here. And we took it from, having to, or we basically took it from a non-isolated state, made it isolated, and then solved it just like we had been doing. Let's do another one here to really solidify this and bring it home. So let's see here. Here's another one here. This is not isolated. There's still some stuff happening here on this side of the equation. We got to get rid of it. We have to inverse this thing. So let's inverse this thing. Combine terms by inverse operations. So minus minus, this becomes x minus 3 equals 10. Now it is in a form that is workable for us to branch off into directional cases that deal with direction. So again, we're going to have two solutions because it equals a positive number here. Positive number. All right, so 10 distance units away. Let's consider 10 distance units away from the negative direction. Let's consider 10 units distance away, or sorry, 10 distance units away from the positive direction. So when we make those considerations, let's see, here we go. I need to inverse this 3 across the equals sign. Let's see, x equals negative 13. Okay, x minus 3 equals 10. Need to inverse this thing across the equal sign to combine like terms appropriately. X equals 13. Do I have that right? Do I have that right? I don't. Let me just make sure I have that right. Let's see. X minus 3 equals, oh, wait a minute, for some reason, oh, wait, no, negative 10, right, plus 3 plus 3, oh, wait a minute, I thought something was off here, minus 10 plus 3 is minus 7, there we go, that makes a little bit more sense. Okay, so now I've got answers here to both, and so the solution set happens to be negative 7 and positive 13. X can be negative 7 if, and this resulting in a true statement if we are considering distance units away and going off to the negative direction. We can consider distance units of 10 going off in the positive direction, resulting in x being 13. And when it is, it makes this statement true. You can kind of see it already. 13 minus 3, absolute value of 10, does in fact equal absolute value of 10. It all checks out. It all checks out. All right, let's do another one. Here. I got to, let's see. This is a variable, right? Remember, treat it like a variable. So divide 6, x plus 2 equals negative 8. Wait a minute, hold on. You should see some alarm bells going off here. Absolute value equals negative number. That doesn't make sense. There's no possible way that can be. Again, because this isn't, the whole point of absolute value is to remove direction from consideration. The whole point of absolute value is to achieve a set, or not a set, but just a value of distance units. There is no such thing as negative distance. Thus, there is no solution. Can't be negative. Can't have negative distance. There's no such thing. Okay, there we go. That was that one. You'll see these. Don't work it. Recognize the form before you start proceeding further, because I recognize that equals -8 right away. I didn't have to do any other work. If you don't recognize it up front, you may be doing a whole bunch of work. One, it'll get you the wrong answer, but two, you'll be just eating away at your time, doing all this extra work for no real purpose. Okay, let's do a few more. We got several more here, and then we'll call this good. We will have explored every possible angle that we can take from this. Okay, so let's do a couple more here. Let's see. Oh, this one's looking pretty complex here, but we can do this. Let's see. Let's start inversing things here. For I do recognize this is not isolated and all by itself. There's this happening to it and this happening to it. Got to get rid of it. Let's do so. -5, -5. We're going to inverse this thing. So now I have 2 times -5n equals 10. Okay, still not isolated. Got to do some more inversing. Got to do some more inversing. Now I have -5n equals 5. Now I am in a state in which I have absolute value term equals positive value, which means I will have two possible solutions. Yeah, this is negative. Don't be concerned that it's negative. And -5n, it's fine. Okay, we're not saying that. Our concern is what it equals. It equals 5 distance units away. Thus, we have two possible solutions. Let's evaluate. So here, let's do -5n equals 5. Let's see, or sorry, -5. And let's see, -5n equals +5 distance units. So -5n, the bars drop off, equals -5. And let's see here, -5. Let's see, I'm kind of running out of space here. Let's see here if I can make it work though. Inverse this thing, divide -5. N equals 1. This here, -5n equals 5, -5, n equals -1. There you go. This is the solution. So the solution set happens to be -1, 1. There you go. That's what makes this whole thing true. Considering negative direction, positive direction, doesn't matter. It's all the same. And then here, let's look at this one here. This one looks a little tough. I have a really big number here, 7 and 87s. Not exactly the numbers I like dealing with the most, but they're not all that scary, guys. So recognize this is not isolated by itself. For one, I want to get it to that. I recognize there is this happening to it and this happening to it. I got to inverse both these things. Let's start with the property of subtraction and addition. So let's inverse this. Let's combine like terms by inversing. So I have this times -5 plus m equals, let's see here, 91. Okay, this is still not by itself. I got to inverse this 7 here, divide 7, divide 7. I have here -5 plus m equals 13. Okay, here we go. This absolute value term equals some sort of positive number, or in other words, 13 distance units away, which means I have to make some consideration as to whether these distance units are toward the negative direction or toward the positive direction. So let's do some stuff here. Let's do some solving and setting up and figure out just exactly what it is. So -5 plus m equals -13. Okay, let's see here. All right, bars drop off. I got -5 plus m equals -13 plus 5 plus 5. This is m equals -8. Okay, and I have this one here, -5 plus m equals positive version of 13. Bars drop off here. Plus 5, plus 5. This here, m equals 18. So now, in totality, I have my solution set right here. It is 8 on the lower end up to 18. And there you go, that's the answer. We have done a lot of absolute value stuff here. We did expressions, we did equations, we looked at scenarios where we had one solution, no solution, two solutions, and beyond. We did so much. We covered a lot of ground, a meaty topic, but important topic as we continue forth in Algebra 1. So we're going to kind of shut the book on the absolute value for now and talk about a few other things. We'll revisit this at a later date, but for now, I think we're in a good spot to part ways, and I will see you on the next one. So take care and have a good day.